that order.
Oh.
Okay, cool. Awesome, cool. So the bacteria monitoring program is one of the programs that Rock Creek Conservancy operates in. Well, mainly we'll be talking about our DC program, but we also operate other bacteria monitoring programs with other partners. So this is going to be focused on what we've been learning so far in this field season. Oh, there we go. So a little bit about the Conservancy first. Our mission is to restore Rock Creek and its parklands as a natural oasis for all people to appreciate and protect. So that means us, people who work for Rock Creek. That means the Park Service. That means all the different local governments, both in Montgomery County, Maryland, and in DC, who use Rock Creek. And also all the people who live near Rock Creek and like to use it as a great recreational space in an urban and developed environment. So the objectives of this training and seminar are to understand stormwater runoff and its adverse impacts on Rock Creek, give insight into bacteria monitoring efforts and results and what they mean for Rock Creek, find avenues to combat stormwater runoff and mitigate individual and community impacts, and connect with other Conservancy volunteer leaders. That is all of you lovely people who have joined us here tonight. So stormwater runoff is probably the big issue that we will be discussing tonight. This picture is, I believe, just the main stem of Rock Creek inside Rock Creek Park portion of the watershed. So on the left is what it would look like under normal weather conditions, and on the right is what it would look like under a stormwater surge. All of that extra water is being washed off from all the surrounding towns, cities, neighborhoods, everything that is within the watershed for Rock Creek, watershed being a geographic area into which all rainfall flows. So Chesapeake Bay is a watershed, Rock Creek is a watershed. And so all of the stormwater that comes into those watersheds ends up in that singular body of water. So stormwater runoff is what happens when rainwater washes off of impervious surface and enters the sewer systems. Impervious surface can be, sidewalks, rooftops, roadways, anything that prevents the infiltration of rainwater into soil. So here you can see a diagram depicting kind of the cycle of how stormwater runoff is generated. You can see all the various places I just mentioned where stormwater lands and does not infiltrate into the ground to replenish groundwater. Instead, it rolls off, collects in our sewer systems, and ends up in our streams, and it carries with it anything that it would pick up along the way. So the when and how of stormwater runoff relates to the quantity of the input, so just the volumetric amount of water. And here in DC and in Montgomery County, we can receive, especially during the summer seasons, we can receive rainwater that amounts to a couple of inches worth of water coming down all within an hour or two. And so that quantity is a lot for streams to deal with. I'll go back to the previous slide and you can see that's what a couple inches of rainwater in a short amount of time does. And you can see just how aggressive the stream becomes. And it's nice because the little tree in the upper right-hand corner of that picture on the left, that's the same tree that's right there in the same spot on the other one. So it gives a good reference point to just how engulfed these streams can become with water during these heavy precipitation events. The quality of the water that comes in has to do with, as I mentioned before, when all that rainwater washes off these impervious surfaces, it brings with it anything that would be residually laying there, whether that would be trash, that could be natural pollutants, especially on roadways. A lot of oily residue builds up and gets washed with the water into the receiving water body. So that is the quantity and quality metrics for stormwater impacts and how they end up in our streams. So impervious surfaces in an urban setting are kind of the bread and butter of where stormwater comes from. And these two maps here show the impervious surface area changes from in Washington, DC and the surrounding areas from 1984 to 2010. And so the darker the blue, the more impervious surface area percentage there is in a given parcel of land. as you can see, as a region gets more urbanized and developed, the amount of impervious surface increases, since impervious surface is necessary to basically all of the things that we would do in an urban developed environment. Housing, businesses, roads, anything that is concrete. Well, I mean, houses aren't made of concrete, but you get the gist of it. Bricks, roofing, everything contributes to impervious surface. So certain cities are going to have an impervious surface percentage of, 70% of their given land area will be impervious, meaning that there's only 30% of the land area where water, when it lands, goes into the ground rather than over the ground. So stormwater ends up in water bodies through drainage systems. And there are two types of drainage systems in urban water catchments. First would be the MS4 system, which is Municipal Separate Storm Sewer System, which is a mouthful. So it's called MS4 in almost any level of government, as well as colloquially too as well. So what that means is that the storm sewer and the sanitary sewer are different. The sanitary sewer carries waste from buildings, from houses, from really any development that is not facing open nature to a water treatment center. And so for us, that means most of our sanitary sewer waste goes down to Blue Plains, which I don't know if any of y'all have been there, but it is pretty cool. It is one of the largest water treatment centers in the world. And it's, I think, the largest of a specific type, which I used to remember when I was studying this in college. But it's very good at filtering out pollutants from the incoming sanitary lines. And it's often said that the water coming out of Blue Plains is cleaner than the water that is in the Potomac, which I think is true. And so that means that the storm sewers are separate from the sanitary sewers. So as you can see in the diagram on the left, any water that gets carried through the storm sewers goes straight into the receiving water body, which, like I said before, since stormwater carries a lot of pollutants with it, can be bad in some situations. But when we talk about the other type of sewer system, you will see why that is ultimately much, much better. So the other type of a sewer system is what's called the combined sewer system, or CSS. This system uses the same sewer line, both sanitary and stormwater, to convey any inputs. So, and that's what a lot of older cities in the United States have carrying their sanitary and stormwater lines. It's generally using the same systems. And in a lot of older parts of DC, the places that were developed first, when city designers were first creating a sewer system, they didn't really, much of stormwater management practices were really unknown at the time, given that this was hundreds of years ago in certain places. And so we've learned a lot since then. And we've learned that when you combine your sewer lines, the sanitary and the stormwater lines together during heavy rain events, the stormwater lines can become overloaded. So in a separate sewer system, that means that when the stormwater lines are overloaded with a heavy precipitation event, the excess flows straight into the receiving body of water. In a combined system, that means that the two streams, the mixed sanitary and stormwater lines, both carry waste. And during a heavy precipitation event, there are certain overflows that are built into the system so that the system doesn't fail when it becomes deluged with such heavy input. So because they're combined, that means that both the stormwater and the sanitary sewage both end up triggering those overflows and ending up in the receiving water body in an untreated state. So you might have seen these along Georgetown waterfront, but there are those warning signs for combined sewer overflow spots that during heavy rain events, it will create an event called a combined sewer overflow event, or CSO. And so that is when there is so much input that the sewer lines can't really manage what's coming in. So they have to just open up the release valves. And so sanitary and stormwater sewage both end up flowing into our water bodies in an untreated way. So that's really, really bad. There are a couple of combined sewer outfalls in Rock Creek. And so during heavy precipitation events, that means that some raw sanitary sewage can end up in Rock Creek. Same is true for the Potomac. Same used to be true for the Anacostia River, and we will get to more of how that's changed later. But for now, separate sewer systems are much cleaner and much safer than combined sewer systems. And so what we do is we try and mitigate and track some of the issues that arise from much of Lower Rock Creek being inside of a combined sewer system. So we'll go back again to thinking about what we were just talking about with stormwater surge. This is a picture that I took at Pierce Mill on September 10th of 2020. It was after a very, very heavy rain. And normally, for those familiar with this area, this is a walking path. I'll use my cursor to help. This is a walking path and a biking path. This is where Rock Creek normally is. But during here, it came up and even flooded. I don't know if water got into Pierce Mill, but it rose all the way to the first story. Here's that same storm further down. You can see how high the water has gotten. I forget exactly how many inches of rain we received during the singular event, but it was enough to basically create a flood zone, 40 feet away from the main body of Rock Creek. And so this is one of the impacts of such a heavy storm surge. And that would be, here you see erosion. This picture was taken by one of our volunteers this summer in our bacteria monitoring program. And you can see like all the massive branches that were washed and caught against this larger fallen tree in Rock Creek. So normally, that water flow that you see there, which is a pretty normal level, that would be not able to carry branches of that size or knock down trees. But these are the residual, casualties of a large storm surge in Rock Creek. And so you can kind of see how this would basically reset specific environments in Rock Creek. Think of a slow meandering stream environment, all of the various macroinvertebrates, amphibians, fish that may live there. And think about the amount of water that you saw in the previous pictures, as well as the amount of water that would be necessary to carry all of these logs and branches, and just the kind of, devastation, but that's a harsh word, given that these are ecosystems that kind of have evolved to respond to these kinds of inputs. But regardless, these kinds of storm surges have tremendous impact on the ecosystems in Rock Creek by basically reconfiguring how the river flows at certain times. Here's another example of stream bank erosion. So this root system is exposed from this tree, and sooner or later, if this erosion goes unmitigated, trees fall into Rock Creek because their banks get so washed out that the trees just can't support themselves with their roots. Roots are a great tool to prevent erosion. They trap soil in place and they keep water from scouring banks fast, but there's only so much they can do. And when the inputs are as high as we saw in some of the previous pictures, this is, very, very not good for the ecosystems that use the stream banks, as well as the stability of the forests around Rock Creek. So here we see one of those sewer outfalls, and it's kind of obscured behind the leaf in front. This picture was taken by another one of our volunteers this summer. She noticed kind of the discoloration of the water that you see in the foreground there. And so this was following a storm. And so what happens in those combined sewer systems is that a lot of the raw sewage can end up in Rock Creek, and it just creates these bacteria hotspots where bacteria flourish, algae that feed on the inputs of nutrients coming from the sewage. That is a very nice way to say that the algae feed off of basically our waste. And so they can kind of propagate and create these spots where it's very, very hard for other organisms to survive. This is not a friendly environment to something like a benthic macroinvertebrate, like a water bug, or to amphibians. This is highly toxic, and it can create areas within streams called anoxic dead zones, where algae blooms are so intense that they use up all of the available oxygen in the water, and the water loses its oxygen content. So organisms that rely on oxygen, such as fish, amphibians, anything else, they can no longer survive in those areas. So here we see some of our water quality data from, sorry, there we go. Here we have a bunch of our water quality data from this past, this is last week's water quality data. For many of you who are familiar with this bacteria monitoring program, I don't see the full list right now of who is in this meeting, but I'm sure that some of you are volunteers that I see every Wednesday morning and who help me take these samples throughout Rock Creek. So this program is run by the Department of Energy and Environment in DC, as well as Anacostia Riverkeeper. And they monitor, how many total sites is that? We've got 8 sites in Rock Creek. And on the map on the right, you can see they range from right where DC meets Montgomery County down to where Rock Creek flows into the Potomac. And I know that many of us may be familiar with the portion of Rock Creek that flows through DC, but only 1/4 of the total length of Rock Creek actually runs through DC. The other 3/4 of it are up in Montgomery County. So they contribute heavily to the watershed as a whole. So we have this monitoring program in Rock Creek with 8 sites where we sample every Wednesday morning. We take E. coli samples, so that's bacteria sampling. E. coli is a good indicator of inputs such as waste into Rock Creek. Then we also take air temperature, water temperature, which water temperature is a very, very, people talk about heat pollution in water, but that contributes heavily to a lot of the algae blooms that I mentioned earlier. Heat pollution can be very disruptive to thermoregulation in other organisms, as well as it can feed into those algae blooms since heat is very good for the propagation of algae. We also take pH readings and turbidity readings, and turbidity is the measure of water clarity. So if water is cloudy, it is very turbid. There we go. And so talking about, I'll go back to these latest readings. So you'll see down here a pass or a fail on our results. So we have thresholds that we are supposed to meet on bacteria counts. This is the primary measure that we have for the general health of waterways. And a pass is under a 400 count, or it's kind of a relative count of bacteria per 100 milliliters of water. So 400 is our threshold. Anything under that is considered a pass. That is a non-hazardous amount to animals. Anything above that means that you could become sick if you come into contact with the water. And so luckily, we saw on July 7th that many of our sites passed, but some of our sites failed. And you'll also see on the second column here, the geometric mean, which after enough data points, we can put together a rolling average of the bacteria counts at each sampling site. And what we've noticed at Rock Creek, as pretty as it looks, it suffers from some of the most heavy bacteria contamination of any of the waterways in DC, and that includes the Anacostia River. As you'll see, there are a bunch of sites in the upper Anacostia watershed, as well as the lower Anacostia watershed. And they generally do a little bit better than the Rock Creek sites. A lot of projects, it's very high profile to remediate the Anacostia River, which we are very, very happy for. But Rock Creek doesn't often receive the same kind of attention, even though it is a stream that plenty of people also use daily. So focusing on the Rock Creek local inputs, we've got, as I mentioned before, the combined sewer overflow. So this is a map of the different kinds of sewer systems in DC. The CSO, or the combined sewer outfall system, is this kind of yellow part. So it takes up about 2/3 of DC is inside of a combined sewer system. So this is like the older, more previously developed parts of DC. So you've got like Georgetown, you've got downtown, Capitol Hill, going up towards like Petworth, Brightwood, that area, as well as much of eastern parts of DC. And so they have the older combined sewer system, and many of those outfalls come into Rock Creek. So this sewer outfall is right near Piney Branch. If you're driving on Piney Branch Parkway, it is kind of that large cement gash that kind of runs next to the road. I don't really know how else to describe it, but it's just like a very big cement space that most of the time is dry, but during storm surge events can see a deluge of water flowing over it into Rock Creek. That is one of those places where during stormwater and heavy precipitation events, it's a pressure release valve for the combined sewer system so that the sewer system doesn't fail. This pink area on the map, that's the separate sewer system. It was installed later than the rest of this when we knew more about sewer lines and how to manage urban stormwater runoff. So here's what we've been finding so far. All of that I shared, 1 week's worth of data before a couple slides ago. This is all of the data that we have so far, organized by site, and each of these columns is the reading on a specific day for equal concentrations. This red line at the bottom down here is that 400 concentration threshold, which is the healthy, quote unquote, level of bacteria in the stream. And these higher peaks, so they do not get higher than 2,420. That is because that is the highest reading that our the analysis tools that we use at the lab that we bring the samples to can output. So this is basically saying the concentrations were so high that they were off the charts, and this is just as high as it gets with our current tools. So these tend to happen after significant rainstorms. You'll see that this date on June 9th, this kind of teal colored column, that was a day where we had heavy storms right before, like 1 or 2 days before we took these samples. And it can take a number of days for the storms to kind of make their way, the water that comes in from the storms to make its way down Rock Creek. So you'll see and you'll notice that like for 3 to 4 days after a heavy storm, the water level will still be really high because, like I said, with watersheds, it is a catch basin for an entire area. So if it rains in the southern part of Rock Creek, where much of DC is, then that water washes into the Potomac pretty quickly. If it rains heavily up in the northern parts, up by like Lake Needwood and the sources of Rock Creek, that water can stay in the system for a couple of days. So if it rains on, say, the Monday or Tuesday before we sample, that means that a lot of what got washed into Rock Creek during that storm is still there. And so that gives a lot of nutrients for algae and bacteria to consume and propagate. So what you're seeing generally with these spikes, barring any other exigent circumstance, these spikes generally correlate with very heavy stormwater inputs. That washes in trash, sewage, other bacteria, and other things that make the E. coli already present in the water that is naturally occurring spike. So it's as you can see, it's kind of a fragile system, with so much impervious surface, there is so much input rolling off and into the creeks that we see these very, very pronounced effects. And you'll see that like the baseline levels at many of our sites are pretty good. The rolling averages right now, because of these spikes on a lot of our sites, are still above that 400 threshold. But on a normal dry weather day, many of our sites fall within the healthy boundaries, but they are so prone to bacteria spikes as a result of stormwater runoff that following a storm event, we're going to see very, very large spikes in bacteria counts. So these conditions aren't really new to this field season. I'm going to take a drink of water right now. We have known for a while now that Rock Creek is heavily impaired, which is the legal term from the Clean Water Act to describe a waterway that is considered otherwise unhealthy for its environment. And so every stream in America generally has unique kind of conditions that the EPA monitors and regulates and provides different metrics for the regulatory agency or government in that area to keep track of. And so our water quality standards, which are listed here in this teal box towards the bottom of the page, give us the range of pH, bacteria, and turbidity that all of our sites should ideally fall within. And so you'll see that, especially with the bacteria one, the single sample value, I mentioned before, that threshold of 400, which is also present here on this red line, this is last year's data, is that 410 parts per 100 milliliters. And the geometric mean being the rolling average that combines all of the data taken every week into one single number to gauge the general quality of the sampling site from which it came from. That should be lower because ideally when the bacteria counts spike, that is the only time that it would go above 400. If you've got a rolling average above 400, that means that your stream site is going to be basically perpetually impaired. And so that's pretty much what we saw with our data from last summer. You can see this general upward trend as the summer goes on, and then the peak fall off basically correlates to stormwater inputs. Like I said before, heat pollution is a big driver of bacteria in water. They thrive off of the higher heat, which is why for our volunteers who do bacteria monitoring, we ask that you put your samples on ice. So that way, between the time where you take your sample and the time it gets to the lab, it hasn't multiplied much further. If it's not on ice, it'll kind of grow inside of the sample bottle and we'll get inaccurate readings by the time it gets to the lab. So as the summer goes on and the water gets hotter, it is easier for bacteria to thrive. It's also the rainy season for us. So we see these kind of spikes. Now this is the geometric mean. So we're going to see fewer of those huge spikes that we saw in the previous chart where the bacteria counts got to, above where our machines could read them to. But combine that with all the data and we have a better picture. It's a more accurate picture of how the water looks in a given season. The single sample value only provides a snapshot. The geometric mean provides data that indicates the general health, not the health at a single point in time. So, like I said, we know that Rock Creek is impaired. We know that bacteria is a large factor. We know that stormwater runoff is a big issue in Rock Creek. It is a very, very, like I said before, it is very, very sensitive to inputs from stormwater runoff in DC, given the fact that it lies so close to the combined sewer system, and because it is a small waterway with a large watershed in very urbanized environment. So when there's a large input, the Potomac, when it gets a couple of inches of rain, the Potomac gets bigger, but it's such a large body of water that it can kind of basically dilute what's coming in. But Rock Creek is small, and the relative change in volume of water that is coming in causes those crazy volumetric spikes that we saw. So back to where is E. coli coming from? We already talked about stormwater runoff, but there are a couple other ways that E. coli can end up in the stream. Rock Creek, being a very, very urbanized watershed, means it lies in close proximity to a lot of sewer lines. And some of you may have seen, just in your own personal experiences in Rock Creek, a lot of sewer lines that run through Rock Creek. And many of them are pretty old. They don't really look like they're in good repair. By and large, we don't see a ton of sewer leaks in Rock Creek, or at least big ones that are noticeable. But since many of these sewers run underground, it can be hard to detect them until they become an issue. Just for an example, we were talking with DC Water at the Conservancy a couple of weeks ago, and it turns out that they had noticed a sewer line leaking near Normanstone Run, which is our RC7 site. So that's in the lower area of Rock Creek, pretty close to where it meets with the Potomac. And they fixed that sewer line. So right now we're trying to see if the data that comes in over the next couple of weeks shows a decrease in bacteria counts, because that would lead us to the conclusion that, oh, this leaking sewer line was having a pretty significant input of bacteria into Rock Creek. So hopefully that is the case and that it fixed it. But if the bacteria levels remain persistently high, that means that it wasn't the sewer line and there is something else going on, and it could just be that much more sensitive to stormwater runoff than we previously thought. So that's something that's ongoing. Right now, there's a couple other sewer rehabilitation projects, both in DC as well as in Montgomery County. Here we have DC Water. Up in Montgomery County, they have the WSSC, which is their local sewer authority. Beyond exposed, broken, eroded, or improperly installed sewer lines, we have wildlife inputs. So E. coli is, as we all know, naturally occurring. It is found in animal scat, human poop, that kind of thing. Dog and cat, I mean, there are people who do walk their cats, so I don't want to single out dogs, but they're a much larger proponent of these kind of wildlife inputs. Oh, pet waste is next. But yeah, wildlife inputs are a big impact on Rock Creek. It is, as we know, a very, very lovely park, and there's thriving animal populations all throughout it, which we love to see because biodiversity is one of the key factors in a healthy ecosystem. You don't want a monocultural ecosystem where it's just a certain number or type of organisms. You want the biodiversity present. So that also means a lot more animal scat gets washed into Rock Creek. There are a lot of birds, a lot of amphibians, and a lot of mammals such as deer. And in northern Rock Creek Park, there are coyote populations too, which we love and cherish, but they poop in the water. So contribute to that E. coli surging level. Pet waste is also something that is, pet waste is also a significant factor in E. coli levels in Rock Creek. That is why we put signs everywhere telling people to clean up after their pets, because whatever does not get cleaned up is going to end up getting washed into Rock Creek at some point, regardless of how long it's been there for. And that is not good for anybody. That's not good for our water quality data. And that gives just a lot of input for bacteria to grow. So one little fun thing that somebody did was source tracing. So every E. coli strain that comes from a different organism has unique genetic markers. So the E. coli that lives within our bodies is different from the E. coli that lives in a deer's body. So somebody sampled E. coli in Rock Creek, and they did genetic tracing to figure out where the strains were coming from. And you'll notice that I've got a big picture of the zoo's front sign in here, because what that person found was they were finding incredibly exotic E. coli in Rock Creek, giraffes, elephants, camels, a bunch of strange inputs. And then it's like, oh, well, there's the zoo that is right next to Rock Creek. And, the zookeepers and the animals, they have to get rid of their waste just the same as any other, human or animal that lives near or in Rock Creek. And so it all, again, ends up in Rock Creek, regardless of where that E. coli comes from, it all ends up in the same place. So source tracing showed that there were a trace presence of those very exotic E. coli strains in Rock Creek, but that kind of source tracing doesn't talk about the relative quantity of where the E. coli strains are coming from. So if you were to break it down by the organisms, the progenitor organism, then you would see very high concentrations of human, dog, deer, that kind of waste. But this specific source tracing study only tested for the presence, not the relative quantity, which is why the results were so all over the place. So that's just a fun little fact of what we found when there was a source tracing project done in Rock Creek. Right now, DOEE in DC is working on another source tracing project. They'll be taking samples, I believe, a couple of times per year at a few different sites throughout the DC portion of Rock Creek and tracing where the E. coli is coming from. And I believe they will be doing that relative quantity tracing so we can get an idea of where the progenitor organisms are. And if, for instance, that helps us inform a lot of our messaging practices. If we find that a high relative quantity of the inputs are coming from dogs, we know then to focus a lot more of our efforts on putting signs in the park saying, hey, please clean up after your pets, and we can reduce this significant input further. So, like I said, what does this mean for Rock Creek? It means that we know that it is heavily impaired. That in real life or real time translates to generally unhealthy conditions for a lot of the organisms that live inside the creek. There are a lot of organisms, benthic macroinvertebrates, which are like these waterborne bugs and crustaceans, that some of them are very, very sensitive to changes in water composition. And certain species are indicator species of conditions in a water body. And so by sampling the concentrations of specific species of benthic macroinvertebrates, we can get a gauge on which species are resilient. And then also that means that if we start to noticing those more sensitive species coming back, we can say, oh, something is improving in the water quality, like something that we're doing is working. So we need to figure out what it is that's working and do more of it. Another impact on visitors is that you're not able to swim in Rock Creek. As tempting as it is, especially on a day like today, it looks really nice. And that's the problem with bacteria pollution, is that it's not the same as turbidity, turbidity being that measure of clarity. The water can look clear, but it can be chock full of bacteria. So super, super unhealthy for people, pets, and kids love walking into the water because it looks really nice and pretty, but highly, highly recommend against that. If you ever see it happening, feel free to tell people, say, please don't swim in the water. There is a lot of E. coli in it, and their parents will most assuredly say, oh yeah, don't go in there, because they know what that means. Yeah. One place to improve, since we know Rock Creek is heavily impaired, and we know that sewer lines are a contributing factor. How much they're a contributing factor is still something to be discerned, but that means that we put pressure on groups like DC Water to rehab their sewer facilities. So here is a article from last May talking about there is a large sewer rehabilitation project going on in Soapstone Valley. This is a picture of one of those exposed sewer lines. And so DC Water will go in, look for any erosion, cracks, breaks, anything, and repair the sewer line so that there won't be as much bacteria leakage. And that bacteria leakage can be independent of stormwater runoff, because these are just, if there's a crack in your sewer line, it doesn't matter what the flow in it is, some of it's going to leak in. Obviously, more is going to leak out when the pressure builds up in the system during a stormwater event, but regardless, we want our sewer lines to be airtight. So I'm going to pass it off to Alayna for this next program. Thank you all for listening to that section on our bacteria monitoring. And now we're going to talk about some of the ways that we can fix stormwater.
Thanks, John. So yeah, as John said, so clearly there's a lot of impairment in Rock Creek, and it's up to us to kind of think through different strategies and solutions to be able to mitigate some of these concerns. So we're going to talk through now a couple different versions of those solutions, starting at the systems level, thinking about how our jurisdictions and how our water bodies are governed and the kind of laws and other policies that go into being able to hopefully improve those bacteria counts and just the overall quality of our water. And then we'll also go through some community level solutions as well as some individual kind of daily things that you can do in your own life as well. Next slide, please. Thank you. So first, MS4 permits are an important piece of this puzzle in terms of being able to solve these problems. MS4 permits operate at kind of the city, state, district level. In our case, the relevant bodies would be Montgomery County and the city of DC. MS4 permits are municipal separate storm sewer system permits, which is a mouthful, that basically just require that particular jurisdiction to minimize and prevent the discharge of pollution into our local water bodies. So over here on the right side of the screen, you can see kind of a brief outline of some of the bullet points in the Montgomery County MS4 permit. Their permit technically expired in 2015, I believe, so they're just continuing to operate off of that same permit. DC's MS4 permit was renewed in 2018 and is continuing to operate for another couple years. So some of the things that these MS4 permits will mandate in terms of the ways that cities or states are approaching their stormwater mitigation are by adding stormwater management to restore streams, reducing stormwater pollution through the implementation of TMDLs. TMDLs are total maximum daily load, and that's a regulatory term through the Clean Water Act. It basically describes, it says here, a plan for restoring impaired waters that identifies the maximum amount of a pollutant that a body of water can receive while it's still able to meet those quality standards. So John was talking through a little bit earlier how different pollutants have different levels of impact on, say, Rock Creek versus the Potomac River. The Potomac River is a much larger body of water, so when it rains and when it receives that stormwater runoff and the pollutants that are within it, it's impacted usually not quite to the same extent that all of that same stormwater would affect Rock Creek, for example, just because it's a much smaller body of water. So when there's more pollutants, it becomes more polluted more quickly. It doesn't dilute in the same way. So TMDLs will differ depending on the body of water and kind of what that capacity for that water is able to take in terms of those pollutants, and still being able to meet that quality threshold. So the implementation of TMDLs is really important to be able to mitigate these. Reducing trash and litter is important. Trash and litter is maybe not the main pollutant that comes in, but it is the visible form of stormwater pollution. So it's, I think, something that is very easy for people to be able to pinpoint and understand, and then be able to also build their understanding to extend that knowledge to the other types of pollutants that are also coming in through stormwater runoff. So here at the Conservancy, we do a lot of trash and litter cleanups as different opportunities to get people involved, but we really hope that that's kind of a gateway into being able to more deeply understand some of these other stormwater concerns. Developing and implementing public outreach and education is also very important. In the next handful of slides, I'll get into one of our particular education campaigns around this. It's very important. I think a lot of people just don't always necessarily know about these issues. Like John said, Rock Creek looks beautiful and gorgeous and sparkling in the sunlight, and it looks like a very inviting place, but it is not somewhere that you want to go into. So just being able to increase our education efforts so that people know that unfortunately it is impaired, it's not safe to go into. So being able to mitigate some of those concerns. There are also county-wide or city-wide, jurisdiction-wide implemented strategies to be able to meet all these permit requirements. They conduct preventative maintenance on stormwater management facilities, and there are a slew of other laws and programs and policies that are implemented more locally to also be able to mitigate some of these things. So this is just an example of some of the steps that are included in the Montgomery County MS4 permit. Again, it will differ a little bit between jurisdictions, but this is a pretty thorough list to be able to think through all of the different types of work that really need to go into being able to mitigate these concerns. It's not just a one kind of implement a stopgap and be able to see an immediate change. Like John said, it's kind of an ongoing process to be able to understand where these different pollutants are coming from, how they may be disparately impacting the water, and then how we can actually take care of them. Next slide, please. The other kind of systems level solution that we can implement is improving our infrastructure. As was noted, it's pretty old, particularly on the eastern side of the city and more southern, some of the older parts of the city. And a lot of those patterns in terms of CSO systems versus MS4 systems also continue north up into Montgomery County. So we also see that same kind of division in infrastructure. A lot of it is very old, just really was not built to be able to maintain the kind of water levels that our rapidly urbanizing area create. With a growing population and also with climate change having larger storm surges, we're just seeing more water enter our pipes. So we really need to be able to improve this infrastructure and make sure that it is able to meet the capacity of our very urbanized area. DC Water has a few different projects in place to be able to begin working on some of this improved infrastructure. A couple examples are the soapstone sewer rehabilitation, which was the article that John was reading the headline for. This program or this restoration project is due to be completed in 2024. It will help to reduce the combined sewer overflows in the area by expanding the capacity of the pipes and being able to provide an area where actual additional water is held before it makes its way through that system and then ends up in those overflow areas. So it's a really important project. It's probably one of the more disruptive projects in the creek since it's actually taking place under parkland. There's a lot of disruption to kind of that trail area, or there will be as they continue that construction project. So it'll take a couple years to get it all sorted out, but I think it will definitely be worth it and really help to improve some of our water quality outcomes in that area, or kind of that northern end. Rock Creek Project B is a newer project through DC Water. This one is more of a opportunity to install different types of green infrastructure. So this includes things like rain gardens, rain barrels, basically just different kinds of things to be able to, with the existing infrastructure, be able to just modify it or otherwise improve it to be able to better be able to manage some of the stormwater. Tree boxes are another example of this. So things that go into place, on our street corners, along the medians, along the trees that are already planted in the area, just to be able to boost their own capacity and being able to filter out some of the water and pollutants that are entering during the storms that we're receiving, and overall just help to be able to filter that out and improve our water quality. So the purpose of these DC Clean Rivers projects, they have a variety of different rehabilitation projects going on throughout the city. These are just two that we're highlighting, but the goal is to reduce CSO events by up to 95% by 2030. It's pretty ambitious, but it's also pretty needed. Again, sewage is one of the major contributors to the high levels of E. coli and other bacteria that we're seeing in our rivers. So it's we're working at least to be able to move toward that and be able to improve our infrastructure to make it a little bit more sustainable. Next slide, please.
These are community solutions to stormwater. Oh, I do want to say one thing on the previous slide. The Kriya Charge, shorthand for Clean Rivers Impervious Area Charge. If you live in DC, you will know that that is a kind of pain in the butt sometimes on your water bill, but that is what that charge for. That charge, it relates to the amount of impervious surface area on your property, and it kind of works on a sliding scale of the more impervious surface you have, the more you contribute to this project. And that's what funds all of these projects to reduce the impacts of impervious surface. So when you see this on your water bill, know that it's helping to fund a lot of these rehabilitation projects to clean up Rock Creek and the Cascade rivers. Okay, community solutions. Rainscapes and River Smart. These are two programs that are operated by local governments. Rainscapes is operated by the Department of Environmental Protection in Montgomery County, and River Smart is operated by DOE in DC. And both of these programs provide financial incentives, mainly through the form of reimbursements, rebates, that kind of thing, for property owners to install green infrastructure, such as rain barrels, green roofs, rain gardens, permeable pavers, shade trees, and more on their property. So you'll see that this is a picture of a rain garden. Rain gardens are specifically designed to both hold or capture and hold rainwater as it rolls off of maybe your roof, off of your sidewalks, off of your driveway. And it creates one more permeable surface for rainwater to flow into the ground and replenish groundwater through. It also, one of the key parts of stormwater runoff is the speed at which it can accumulate. So when it all comes off of impervious surface, it can go really, really fast and through these sewer lines very, very quickly and scour banks, cause erosion, carry trash, carry logs, whatever. So slowing down rainwater is one of the best ways to reduce the impacts of stormwater runoff. If you can keep 2 inches of rain that comes down in 1 hour from accumulating as 2 inches of rain in short bursts, if you can dilute that 2 inches over 3 to 4 hours, that is immeasurably helpful to receiving body of water. So just slowing down rain is a huge part of preventing stormwater impacts, which is why trees are some of the best things that you can do, as well as other vegetation, to slow rainwater as it flows. So these are programs that if you're interested in, you can get people from these agencies to come and check out your property and see, hey, maybe a rain barrel would work here to collect rain from your roof and prevent it from going into the sewer, or maybe a rain garden would help to replenish groundwater as well as grow a nice, herbaceous, beautiful garden. So if you're interested, those are the appropriate agencies, and you can just Google those programs and it'll lead you to pages where you can possibly get signed up. Dynastar Disconnection is a program that we, Rock Creek Conservancy, and you'll see some of our beautiful employees, we work with DC Water to, as the title goes, disconnect downspouts from roofs. And it's not just every roof, it is mainly within the portion of the Rock Creek watershed that receives combined sewage systems. So that means a lot of Ward 4, Ward 1, are project areas that we've been working on for the past couple of years now. This is Tavon, he is the leader of this program that we do with DC Water. And they go around to houses in these project areas and they determine if these houses would be eligible for disconnection. Disconnection means that, normally there'd be a standpipe where your roof gutter goes into the standpipe and that just connects directly to the sewer system. When we disconnect them, we need to make sure there's enough permeable surface where the runoff from your roof would be able to run onto the ground and soak into the ground rather than just going straight into the sewer system and potentially causing an overload and a combined sewer overflow. So these is all free of charge if your house is eligible. There are certain parameters your property would have to meet so that it can receive that extra rainwater and there's no risk of flooding or anything like that. So we canvass for eligibility inside these project areas, and we disconnect eligible homes where the homeowner says, yeah, I want to do that. I want to disconnect my gutter from the downspout because, you know, it seems to make sense. And this is what sustainable cities would kind of look like. There's also the option to get a rain barrel stored so that some of that water can get diverted into here and you can use it for gardening, for washing your car, various other things. And this is all, again, free. There's conservation landscaping. This is remodeling of relatively substantial portions of land to, as I said, slow down the flow of water and increase the capacity of the land to hold that water. So all of these portions of this landscape help to either slow, trap, or contain water. So these rocks, you know, water coming down here at high speed will hit these rocks, and these rocks aren't really going to move. And so they're going to basically capture a lot of that force of the rainwater coming down. So that way the rainwater then doesn't erode a lot of the delicate stream beds that help to trap the water through porosity. Porosity is the property of soil to hold water, and a higher porosity means that the water can flow through that soil. Lower porosity, like clay, means water flows over that soil. So you want high porosity with variable grain size, so that way a lot of grain size being the size of the particles inside the soil. So that way it can hold as much water as possible, basically acting like a sponge and releasing that water slowly once it is saturated. Saturated being the quality of the soil where it can no longer hold water. So the stones dilute energy and dissipate force, so there's no erosion. The soil here helps to capture, and once the soil is saturated, water flows over it in a meandering fashion. Meandering also helps to reduce energy. If water becomes channelized, it's going to flow really quickly. And so stream channelization is very, very indicative of erosion and stream bank failure. Stream bank failure being like that root system we saw earlier getting carved out and the trees falling into the stream. So these are designed to just, again, slow and hold water, and they look really pretty if you do them well. Green Streets is another program that is operated by the Department of Environmental Protection in Montgomery County. And these are roadway green infrastructure installations. So they create these aesthetically beautiful installations. These are tree boxes over here, and this is a rain garden over here. So water from the storm sewer will flow into the rain garden. It'll sit there for a while, it'll slow down. And then once it hits a certain point of there being too much, this little cap here will drain the water so it doesn't overflow onto either residential property or back into the street. So these are great for, again, just slowing down holding water. Trees, very important. Trees are the cheapest and most effective stormwater management infrastructure that you can create. It cannot be understated the effect that a healthy canopy cover has on both stormwater management as well as reducing urban heat island effect, which is another related issue in urban systems where areas with trees are a lot cooler and therefore a lot healthier for humans to be in during hot summer days like we have than places without trees, because the hot pavement is just going to sit and collect heat and fester. Trees are amazing, great, beautiful things. If you want to reduce stormwater at home, plant a bunch of trees. If you want your local politicians to help mitigate stormwater, getting them to support tree canopy goals. DC has a very good one of, I believe it's like 35% tree canopy coverage throughout the city by 2030. I could be entirely wrong on that. It's been a while since I worked on it, but that is, having those goals is a great way to combat climate change in a really, really cheap and easy and just beneficial for everybody kind of way. And also planting trees in neighborhoods that don't already have a bunch of trees is going to do a lot more than planting trees in neighborhoods that already have a bunch of trees. So stormwater solutions to individual. We're going to go back to Alayna for this.
One more quick note on tree canopies and the heat island effect. One cool fact about Rock Creek, there's been studies that have been done taking the heat island effect into account in Rock Creek, and then also looking at it in a more densely urbanized area of the city. For the study that they did, they looked at Georgia Avenue, which is, very lots of impervious surfaces, lots of businesses, that kind of thing. And they found that it was about 17 degrees cooler on a hot summer day down by the stream in Rock Creek than it is like out on the pavement in Georgia Avenue. It's pretty amazing the difference that you can see when you have all of those trees there to be able to absorb that carbon and reduce the heat. Go ahead. So now for our final section of the training tonight, we're going to go over just a few of the kind of individual solutions that you can also be doing in our daily lives, or encouraging our friends, our neighbors, our peers, our families to be doing in their daily lives to be able to help mitigate some of these concerns. Next slide. Thank you. So first, I just want to talk a little bit about the Recreate Responsibly campaign. This is a campaign that we kicked off in partnership with Rock Creek Park, the National Park Service, right around the beginning of the pandemic. Recreate Responsibly is originally a national campaign for the National Park Service. Again, that was started right around March of last year. And it was really meant initially to be able to reinforce some of the pandemic-related messaging that was really needed in our parks. So obviously there was a huge uptick in the amount of people who were going into parks during the beginning of the pandemic, as people were looking to be able to get outside, be able to exercise. It's so good to be outside for your mental, physical health. So when parks were seeing this kind of resurgence of visitors at the beginning of last year, they created these messages to help remind people to wear masks while they are outside, to remember to social distance on trails and be respectful of each other, all of those kind of basic public health type messaging. Rock Creek Park in the National Park Service, as an urban park, I think has some slightly different challenges in the way that those increased visitor rates were impacting our landscapes. So they partnered with us to be able to develop this messaging campaign and share some of these general stewardship messages of how to recreate responsibly, how to be safe and keep yourself, your family, your pets, everybody safe when you're out in the park. So the very first thing that we kicked off was really born out of what we were understanding through our data collection efforts from bacteria monitoring last summer and previous years. But obviously Rock Creek is incredibly impaired. There's a swim ban in the park, so you're not actually allowed to wade or swim in Rock Creek. People do all the time. So it was up to us to be able to help spread some of this messaging and awareness around just why that's a bad idea. Not only is it not allowed, but there are actual very real public health concerns if people are getting into the water in terms of their contact with bacteria and E. coli. So this was a very kind of simple sign, again, just encouraging people to stay out of the water. This little graph over here on the side is data taken from our bacteria monitors last summer in 2020, along with the actual bacteria monitoring and taking water samples and doing all of that kind of stuff that our bacteria monitors do diligently every single week. Volunteers were also taking just kind of visual visitor use data. So while they were at each of the 8 sites within Rock Creek, they would take a look around and see how many people are in the water, how many people are walking dogs. There's a handful of kind of visitor use benchmarks that were also being recorded during that time, just to give us an understanding of how the park was being used and kind of what some of those things might be going on. This particular data point was looking at the number of children in the water in Rock Creek. So this is aggregated from all of the Rock Creek sites together. And it's kind of exciting. You'll see there's a really big peak in the middle of the summer, about mid-July, but then there's also a pretty significant drop that takes place immediately after that, between the 15th and the 22nd. That's when we began to implement this campaign. Many of you might have seen these signs, or on kind of plastic yard signs out throughout the park. So they are really in use and hopefully visible to visitors who are coming to recreate throughout the park. And we have found that it has been, at least anecdotally from the data collected from our monitor volunteers, that it has been pretty effective. People, once they are beginning to understand that the water is impaired, that it's not safe, it's not healthy to go into the water, we really are starting to see at least a slight change in terms of that visitor behavior and hopefully healthier outcomes in terms of our park visitors. So that was pretty exciting to see. We are continuing to collect that type of data for this summer, so we don't have a report on that yet, but we have only increased the number of signs, both for this particular message and some of our other Recreate Responsibly messages. So we're really hoping that they are effective in helping the people stay safe and healthy in Rock Creek. Next slide, please. you. This is another component of the messaging as a part of the Recreate Responsibly campaign. So as John talked through pretty extensively earlier, pet waste is another big contributor to the bacteria levels that we are seeing in Rock Creek. Obviously, dogs are very welcome visitors throughout the park. I always love seeing dogs, out on hikes and walks and such. But unfortunately, a lot of people do not pick up after their dogs after they leave waste. Sometimes I'll see like they bag it, but then drop the bag, or sometimes they just don't touch it at all. So that's one major concern with dogs, particularly as it has to do with water quality. The other issue that we see with dogs that's a little bit less related to this particular conversation, but is still important, is that dogs are often left off leash and allowed to just kind of wander on their own. Again, this has less of an impact directly on the water quality, but it really does impact forest health in our parks. Dogs off leash can trample sensitive species. Invasive plants are a really prominent threat in Rock Creek. And so dogs trampling can either introduce new invasive plants or help carry their seeds to new areas throughout the park, or they can trample very sensitive native plants that we really want to make sure that we are protecting and allowing to thrive in the area. Dogs can also stress out local wildlife. The scent of a dog can remain in an area for several hours after a dog has come through. And sometimes if a bird or squirrel or whatever it might be can smell a dog, even if the dog is no longer there, they won't leave their habitats, won't leave their holes to go out and do things like find food, mate, bring food back to their children, things like that. So there's a lot of different concerns that have to go with keeping your dog on a leash. So it's very important that you always keep your dog leashed and that you always pick up pet waste and properly dispose of it. Don't just bag it up and then drop it on the ground, which I have never understood. So we have a handful of these signs that are out throughout the park. I'm sure that, again, as you're using the park, many of you have probably seen these out and around. In addition to the signage to help just with the general education around this concern, we also have been partnering with the Park Service and a handful of other partners to install these pet waste stations at a few different sites throughout the park. There are no dog parks in Rock Creek Park, so technically everywhere in the park is somewhere that you should be remaining leashed or have your dog leashed. But we also wanted to make sure that there were at least the resources available to folks. Sometimes you just, genuinely forget to bring a bag with you, or don't know where a trash can is. So by installing these stations, they have these 2 dispensers for pet waste bags that then people can use and grab and be able to properly dispose of that waste. And there's usually a trash can also right next to it, so that there's no confusion or excuse to be able to, not be able to find a place to properly dispose of it. So this picture is at Fort Slocum in Northeast DC. Actually, it's Northwest still, over in Northwest DC in the upper part. But there's a handful of other pet waste stations throughout the park, and hopefully they are providing the resources and opportunities for people to be able to better take care of their pet waste. Next slide. So in addition to some of these, kind of individual recreation concerns, it's really imperative for all of you as people who care about Rock Creek, as volunteers with us at the Conservancy, to really help us get the word out. I think trainings like this are really great because we can help educate all of you on some of the specific data findings and different things that we're seeing in Rock Creek. But if it doesn't leave this room, then unfortunately, it's not going to do a lot. So we really count on all of you to help be ambassadors for Rock Creek, help speak up about the concerns that we're seeing in the area, and help encourage your, again, friends, neighbors, family members, other park visitors that you might run into, whoever it is, to always recreate responsibly, to make good decisions, and be able to treat Rock Creek with care. So a few examples of things that you can help spread the word about after tonight are programs like River Smart and Rainscapes that John talked about. Those are really great kind of community and household opportunities to get involved and be able to install green infrastructure right where you live. Adopt a Stream and Stream Team Leaders are 2 programs that we have. I think a few people here are trained in those programs, where we go a little bit in depth in terms of the stormwater concerns that we're seeing. We will train you to host your own cleanup events, to be able to deal with the trash and litter component of that stormwater runoff, and then also be able to share some of the broader messaging around stormwater concerns that we're seeing. Downspout Disconnection, again, if you are in the eligible area in DC, another great opportunity to install green infrastructure at your home. The Conservancy has lots of volunteer events, and we always encourage you all to come out and participate with us. Every single Saturday, we host a volunteer event somewhere in the park. We tend to rotate between our 5 mini Oasis locations where we are really focusing a lot of our restoration work. But these are opportunities to learn more about some of the issues that Rock Creek is facing. Primarily, we will talk about different stormwater issues as well as invasive plants. To actually get involved, hands-on, spend a morning doing some service and giving back and helping to mitigate these issues, to meet other people who are like-minded and also care about these issues. I've always been very impressed since my time here with just the passion and fervor of the Rock Creek community. And so I always appreciate being able to go out and meet volunteers and others who are also working toward improving Rock Creek. If you are trained in one of our volunteer leadership programs, there are always the options to give talks and presentations about some of these issues yourself. I know many of you are connected to your own communities, whether that's a faith institution, Girls or Boy Scouts, a particular school, whatever it might be. Many of you are connected to communities who could also benefit from hearing presentations like this and from learning more about Rock Creek and how to protect it. So at the Conservancy, we have a handful of resources, including slide decks, different trainings that we've done previously, things like that, and are always happy to share those with you or develop something new if there's something that we don't have. So if you are ever interested in hosting a talk or presentation with a group that you are involved in, please just let us know, and we are more than happy to help support you in that endeavor. And the final piece is general community advocacy. John at the Conservancy works quite hard on our advocacy efforts to really be the voice of Rock Creek. There are a handful of different city and statewide things, depending on if we're in Montgomery County or DC, that will really heavily impact the use of Rock Creek as well as the impacts on Rock Creek. So one recent example is the expansion of 495 up in Montgomery County. That portion of the bridge runs directly along Rock Creek, and they were going to expand it by a couple lanes. That would have had an immediate impact on the stream that was directly next to it. So we and a bunch of other partners helped to advocate for an environmental impact assessment to just kind of slow down the county and their private partnership progression. And so it's now at a place where they are pursuing other alternatives other than just going in and expanding without thinking about the impacts to Rock Creek. So there are a lot of different community advocacy opportunities. That was one big example, but there are a lot of different ones within your own communities, within your own neighborhoods, and other things that we're working on. So if you ever see anything that you think should come to our attention or should be more of the attention of the Rock Creek community, you're always welcome to come to us and talk through that, and we can talk through what maybe an advocacy strategy can look like or how we can support you in that work. But there are a lot of different ways to be able to talk about Rock Creek, to support Rock Creek, and we hope that you all are leaving tonight with a few different ways that you can help to continue these conversations, continue getting the word out, and continue kind of developing that stewardship ethic that we're really hoping to see across the broader Rock Creek community. Next slide. Yeah. So thank you so much for coming tonight. Really quick, I do see a question in the chat now. I'll get to that in just a second. I just want to touch on the upcoming opportunities. We have, again, lots of volunteer opportunities, but also lots of community events and other things like that that are going on. Every Thursday this month, we will be hosting Summer in the Parks events over at Fort Circle Parks in Northeast DC. It's just off South Dakota Avenue. We'll have lots of games. We have partners coming, I think some popsicles and some other fun things like that. So definitely come out and just celebrate Rock Creek with us. We're just excited to be back together as a community. So join us for those events this month. There is a Women in Park Leadership virtual conversation that's taking place on July 27th in the evening. All these opportunities can be found on our calendar, so please register if you're interested. But that'll be an opportunity to talk with Julia Washburn, who is the current superintendent of Rock Creek Park, Tara Morrison, who is the former superintendent of Rock Creek Park and the current superintendent at National Capital Parks East, and Georgia Ellard, who is the first Black woman who served as the superintendent at Rock Creek Park. We have a couple of Latino Conservation Week events coming up, one in DC and one in Montgomery County, so join us for those. And John is also looking for Montgomery County bacteria monitors. So if you were inspired by this presentation and want to do everything you can to help us better understand bacteria levels in Rock Creek, reach out to us and we can get you hooked up for that program.
That pretty much says it all. Thank you all for joining us. And again, you guys are our Rock Creek stewards. These are all of our partner organizations who help fund some of these programs. So good shout out to them. Yeah, you guys are all Rock Creek stewards. And so having you all, stop sharing, present and interested in the work that we do means that we are reaching our community and that we have people who understand these issues and can talk to their community about Rock Creek issues, as well as advocate for better policies. I mean, a lot of this stuff comes from local governments and what they can do to reduce stormwater impacts. So being conscious of what, I mean, thankfully we live in places where our local governments are making pretty good headway on stormwater management and water quality. But you know, there's always more work to be done, and there's always ways that we can push for healthier environments for all of us. So let's go to the chat for any. Oh, okay. Cool. We got a question. So thank you. Okay, cool. Only question is how to participate in water testing in Upper Montgomery area that feeds to Rock Creek Watershed. That is perfect because that is a program that I manage. And so Audrey would be happy to talk with you more about that program. I will send my email in the chat. So if anybody is interested in following up on any of this stuff that we talked about today, please do not hesitate to shoot me an email and I will get back to you as soon as I possibly can. Thank you all again for joining, and we'll just keep this room open for a little bit in case anybody else has any questions.
Thank you all so much.
Thank you very much.
Yeah, I hope this was informative.